All right, so today we're doing function compositions. Now, when you're composing functions, what you're doing is you're taking one function and you're putting it inside of another function. So for number one right here, I'm given two functions. I'm given f of x, which is equal to x squared, and I'm given g of x, which is equal to 3x. And what I want to do is I want to find g of f. G of f. And I want to evaluate it at x, which means I'm actually going to be finding a function. So what does this mean? Well, this tiny circle right here in the middle, that means composition. That's basically the composition symbol. And when I use a composition symbol, what I'm doing is I'm taking f and I'm putting it inside of the function g. So what is that going to look like? I'm going to have the function g going first, since it's first in the composition, and I'm going to be evaluating the function g at the function f of x. And since I have two sets of parentheses, I need to make sure I close up two sets of parentheses. Okay, so how do I start this off? First of all, I'm going to replace f of x with x squared. I know that f of x is equal to x squared, so all I'm going to do to start off is replace f of x with x squared. Okay, so now I need to figure out what g of x squared is. What does that mean? Well, that basically means that I'm going to take the function g of x, and everywhere I see an x in that function, I'm going to replace it with an x squared. So when I do that, I'm going to keep everything about the function the same. I'm still going to have the 3 out in front, but instead of having an x, I'm going to replace that with this x squared that's on the inside. And then 3 times x squared is going to give me 3x squared. That is my composite function. The next thing I want to do is I want to find the composite function of f of g of x. So what does this one mean? This one means that I'm taking f and I'm writing that first, and I'm going to put the function g of x inside of f. So this time I've switched the order of the two functions. Notice that I'm taking the function g this time and I'm putting it inside of f. So what is g of x? Well, we know that g of x is equal to 3x, right? So I'm going to replace this g of x with a 3x. So let's see what that looks like. F of 3x. So all I've done is I've replaced that g of x with a 3x. And now I'm going to evaluate the function f at 3x. So what that means is I'm going to take the function f of x, and everywhere I see an x in this function, I'm going to replace that x with a 3x. So I'm going to get the quantity 3x squared because I have that exponent of 2 on the outside. So that means I'm going to square everything on the inside of the parentheses. I need to square the 3 to get 9, but I also need to square the x to get x squared. And I'm done. There's nothing left I have to do. So see how these two functions are different? For the first one, you're putting f inside of g. But for the next one, you're putting g inside of f. So the order of that composition matters. So when you're composing two functions, you're always taking one function and you're putting it inside of the other to get a brand new function. And I hope that helps.